Despite the fact that they seem as distinct objects in an otherwise black sky, galaxies are actually a part of a vast web of gas and dust from which they have evolved. What can it reveal about how galaxies formed, and where is a galaxy's edge, in light of this? By identifying the borders of almost 1,000 nearby galaxies using a novel definition of galaxy size, researchers learned numerous important facts about how these galaxies started and evolved. The researchers, building on their earlier findings, use what they refer to as a critical gas threshold to connect a galaxy size to its star production. Although cold gas is present throughout the cosmos, stars can only form if its density exceeds a specific threshold. When the gas density drops below this crucial threshold, scientists contend that the edge of a galaxy is characterized as the point at which star formation within the galaxy significantly declines. These decreases in star formation have previously been seen as sharp declines in the ultraviolet radiation measured in these areas. However, this characteristic can also be seen at optical wavelengths, which is how scientists were able to distinguish their edges. In order to quantify how the light varies from these objects' cores out to great distances, astronomers needed high-resolution photographs. The Sloan Digital Sky Survey, an optical telescope in New Mexico, USA, has been making repeat observations of the whole northern sky for more than 20 years, and they use data from this source. The astronomers calculated the distance from the galaxy's core at which they saw a strong change or dip in light, and they located this feature's outermost point. They were able to learn more about how these galaxies began and evolved by identifying the margins of roughly 1,000 galaxies, ranging in size from low-mass dwarfs to massive ellipticals. After measuring the galaxy edges, the astronomers sought confirmation of their crucial density theory. To do this, they examined the star densities at the observed edges and discovered that there were, in fact, 3 crucial densities that varied depending on the structure of the galaxy. Edge densities are lowest in diffuse, low-mass galaxies. They rise in spiral galaxies like the Milky Way, and they are highest in large, elliptical galaxies. The scientists discovered physically motivated definitions of a galaxy's edge for the first time. This escalating material density in the periphery also demonstrates that high-mass elliptical galaxies are more effective at star formation than their low-mass counterparts. They then looked at how their size changed with the galaxy's total star mass, and discovered the highest correlation between these two measurements ever observed, 3 times stronger than with other approaches, with the smallest galaxies having the least mass and the largest having the most. The fact that galaxies of all sizes and shapes are represented in this connection raises the possibility that galaxies produce their stars via a similar process. Regarding the nature and significance of these findings, there are still many unanswered concerns, such as whether they apply to galaxies in the early universe and the influence of the galaxy's environment. Nevertheless, they have the potential to be highly intriguing.